This time topic is Bohr's model of a hydrogen atom. To study this, let's review what we learned in previous classes. We learned the Coulomb force, which is between two charged particles, F is 1/4 pi epsilon naught, two charge multiplication divided by distance squared. And you also learned the Newton's second law, F is mass times acceleration. And when you have a rotational motion, the acceleration is v squared divided by r, and kinetic energy is half mv squared. And potential, electric potential is 1/4 pi epsilon naught integration with respect to charge distribution divided by distance. And potential energy, when you have charge in potential area, we have potential energy, which is charge times potential. And we learned the angular momentum is distance and momentum cross product, R cross P. If we summarize all these reviews we just came through, is this force, electric force, and Newton's second law, acceleration, kinetic energy, and potential, electric potential, electric potential energy, and angular momentum. What Bohr did is he postulated the angular momentum for electron orbiting around the nucleus is nothing but some natural number times reduced Planck constant. So here n is a natural number. It's not integrated, it's not a real number, but it's a natural number, 1, 2, 3, like that. So angular momentum nh bar, but we also know it can be expressed in terms of r and momentum p cross product. Cross product, the magnitude is we have a sign value between two vectors. In rotational motion, the direction, electric direction and radial direction, we have a right angle, so the angle theta is 90 degrees, so sine 90. But sine 90 is nothing but 1, so L equals Rp. But momentum is mass times velocity, so it becomes Rmv. From this, we can calculate speed of electron in orbital motion. So V is nh bar division by Rm. Electric force, which is Coulomb force, is 1/4 pi epsilon naught, two charge. Now here we have an electron orbiting around. In general, in nucleus, we have a certain number of protons. So here, capital Z stands for number of proton. So we have Ze, positive charge in nucleus, and division by distance squared. But Newton's second law is ma, mass times acceleration. Instead of rotational motion, acceleration is v squared by r. Now we calculated v in previous slide. There was nh bar of Rn. We plug that into this v, then that gets squared. Then simplified, then it becomes n squared, h bar squared, divided by r cubed, and mass. Which means the top portion of 1/4 pi epsilon naught is z squared, r squared equals to this. For the hydrogen case, z is 1 because we have 1 proton in nucleus. So from that, we can calculate the radius of electron orbital motion. So R becomes this value, 4 pi epsilon naught E squared, division by E squared, N squared, H bar squared, M. But here, 4 pi epsilon naught E, M, H bar, these are all constant. So we can correct them as a one constant, symbolically use A naught it has name as known as Bohr's radius. So n square, that is variable. A naught n square, A naught, A is at 4 pi epsilon naught, h bar square E and E square of m. Now, if you evaluate this A naught, which is Bohr's radius, using these values, 1 over 4 pi epsilon naught equals 9 times 10 to the 9 Newton meter square per Coulomb square. H bar is 1.055 times 10 to the power negative 34 joule second. And unit charge is 1.6 or 2 10 to the negative 19 Coulomb. Electron mass is 9.1 times 10 to the power negative 31 kilogram. If you plug those values into here, then you get Bohr's radius approximately 0.0529 nanometer. What that means is, because A naught is some number constant, so R equal A naught n square means electrons, they have only certain allowed orbits. Now the n, as we mentioned earlier, is a natural number, which is 1, 2, 3, 4, like that. So n cannot be any decimal value, which means the electron cannot exist in between orbital pathway. Speed equation, we derived n h bar of Rn. Now we have another equation for radius, which is A naught times n. So we plug that in, then we have this h bar over nm A naught. If you do one calculation, for example, quantum number, principal quantum number n equal 1, which is the orbital pathway closest to the nucleus. Okay? In that case, n is 1, then h bar over m A naught. If you calculate this, h naught value, m value, and A naught value, then we have 2.2 times 10 to the 6 meter per second. This value, if you compare with the speed of light in vacuum, is just less than 1% of speed of light. The C with speed of light is 3 times 10 to the A meter per second. If you calculate energy, total energy, kinetic energy, and potential energy summation, kinetic energy is half mv squared, and from the fourth equation, we have 1 over 4 pi epsilon naught GE square over R squared. That equals mv square over R. From this, we can find the expression for mv square, which is GE square over 4 pi epsilon naught R. And potential energy is negative integration R to infinity. This is we learned the last time, the last class. It's ZE square over 4 pi epsilon naught R squared, and integration with respect to R. If we do this integration, we have a negative ZE square over 4 pi epsilon naught R. So total energy becomes, if you plug in potential energy and kinetic energy, we have a half G square 4 pi epsilon naught R minus 4 pi epsilon naught, 1 over 4 pi epsilon naught Z square divided by R. That becomes negative half 1 over 4 pi epsilon naught Z square over R. Now R, we found the expression for R. We use that here, okay, which is 4 pi epsilon naught h bar square n square over Z square m. You plug that into the energy equation, then energy equation becomes this form. It has a lot of constant values. If we plug in all the constant values, then we have this expression, mass of electron, unit charge E, and 1/4 epsilon naught, H bar, which is a reduced Planck constant, plug all those in. Then what's left is Z square over N square is left behind. Z is nothing but number of proton in nucleus. So if we simplify those numbers, what we have is negative 21.8 times 10 to the negative 19 power joule times Z square over N square. We change this to smaller unit, which is electron volt. 1 electron volt is 1.602 times 10 to the negative 19 power joule. So if we use this, then we have this expression. Energy is negative 13.6 electron volt times Z square over N square. For the case of hydrogen, Z equals 1. So if we plug 1 in here, then we have a negative 13.6 division by N square. N is a principal orbital quantum number, which is a natural number. What that means is energy also can be only permitted values only. It cannot be any values, because N is natural number. If N increase, which means electron location is going far away from the nucleus, okay, then there will be eventually ionization will happen. And experimentally, we came to know the ionization energy of a hydrogen atom is 13.6 electron volt. Now, if we summarize what we learned in this lecture is speed of electron for orbital motion is nh bar over rm, and radius we can calculate using Bohr radius a naught times n square, and energy is simply negative 13.6 electron volt times number of proton squared divided by quantum number squared. Bohr did all these good calculations, but there is a limit. For example, Bohr's calculation cannot explain the bonding of atoms into molecules, like ionic bonding or covalent bonding. However, the Bohr's work is very important, as it is the beginning of quantum physics. Thank you.